I mean, I get it.
You don't know how to do it?
I do. But there's some problem out there in the world that I don't know how to do. I mean, I don't know everything. But it just it's a higher like mental requirement. So is this thing going? Do I have it off? Okay. All right. So and I'm going to try to make this as painless as possible and teach you some strategies for working through problems like this so that you don't have to be so afraid of them because it's really just about figuring out what information is important and what isn't. A lot of times it's overwhelmed. You're like, oh my God, what am I supposed to do with this? So the first thing I want to make sure you write down on your notes. Hold on. It hates me. That's okay. Here we go. All right. So for the word problems, we're just going to abbreviate the basic exponential function to a times b to the x. We're not going to really deal with c and d in these right now. So we're just going to deal with the a, the b, and the x. So, and we're only going to need to find two values to work these out. And that's the a and the b. The x stays the x, okay? So the a is the initial value or the starting value. And the b is the growth or decay factor. I'm just going to write growth factor. And in general, x represents the time. Not always, but most of the time. Okay. For our purposes, that's what we're going to be dealing with. But the only things you need to pull out of that word problem are a and b, because I give you the situation and the instructions ask you to write the function that models that situation. Okay, so that's what we're going to deal with first. So let's read it. I know that I need to find some a and some b. Oh, I forgot something. Let me do one more thing in the notes up here. For values of b in the word problem, if it is a growth situation, if it's an increasing, then our b value is given by 1 plus the percentage as a decimal. If it is a decay, or the value is decreasing, it would be 1 minus the percentage as a decimal. Okay? So in 2016, the population of school children in a city was 500. This population increases at a rate of 5% a year. So the first thing I'm going to determine here is this a growth or decay situation? Growth, because it says the population is increasing. Good. So that's my first thing. I've got to know that before I find the correct growth factor here. So remember that B is just, this is growth, so it's 1 plus the growth percentage as a decimal. What is the percentage of growth? 5%. So as a decimal, that would be 0.05. Nope. What is that? Nope. All right. So if we go ahead and combine these like terms here, right, these are just two things. This is 1.05. So that is my growth factor. That's the B. And look, I've got half of what I need. So now I only need this A value here, which we know is the initial value. So what is the initial value? 500. We start with 500 kids. So that's what it is. And then from this point, I mean, the hard part is over. We've made these three determinations. And now the a goes in where the a is. So to write the function, we just say f of x is equal to a, which is 500, times b, which is 1.05 to the x. And there's your function.
That wasn't terrible.
No, it is not. Not at all. So notice the second part of your instructions say, then use Desmos to graph the function and answer the question. So right now, I want you to pull up a tab, type in desmos.com, and click on Graphing Calculator. We're going to do this together. I want you to be able to type it in and see it too, because you're going to need to manipulate it. Now, is there a way to algebraically solve for x in the exponent? Absolutely, but you do not know how to do that yet. Okay, so we're going to use the graph. I'm going to expect you to know how to use both. later in the unit, I'll teach you how to solve this without the graph. Okay. So what we want to do, if you've got the graphing calculator pulled up, I'm going to do it with you on the big board there. So I just want us to graph that function. So you can just put in f of x. Oh, maybe I should oh, it's slow. God love it. All right. Where's my function here? There it is. We'll have 500. If you're unsure of how to make that times, like the multiplication, it's just the asterisk, right? There's the star. And then 1.05 to the x. Bless you.
Thank you.
So the immediate issue I'm noticing here is, where is my graph? Well, remember our initial value is at 500, so I'm just going to zoom out. There it is. All right. So here's my starting value at 500. So time at the beginning or at the start is at 0, right? So time is the x and the value is the y. So it says, what's my question here? I lost it. Does it say the population of the school children?
I'm about 750.
Okay, so it wants to know when the population is at 750. So see my starting value right here? I'm going to click on it. And I'm going to drag that up the graph if it'll let me. I need to zoom in some more. Here. Why? Anyway, I'll just do it like this. There we go. So see, this is about 1.13 as far as time. And then let's go until it's above 750. Ooh, I'm going to have to zoom it up some more. Because that y value is the number of school children. And that x value is how long it's taking. There we go. So about how long does it take? About 8 years, right? So notice the y value is the number of school children. Remember, I told you x is time. So we're just going to drag that up until we get the desired value and look at the time it took to get there. So it's about 8.3 years. Questions? Yeah, let's do another one. Let's get rid of that graph. Let's go back over. Let's do number 11. And then we'll go back and do number 10, okay? All right, so again, we just want to remind ourselves of the general form that we're looking at here. And that's y equals a times b to the x, where a is the initial value and b is the growth factor. Remember, step one, is it growth or decay? Let's read it. The cost of a new car is $32,000. It depreciates at that rate. That means that it loses 15% of its value per year. Is this growth or decay?
Okay.
Decay, right? The value is going down, it's decreasing. So that's going to be 1 minus. What is the percentage of decay? 15%. As a decimal, that is 0.15. And so 1 minus 0.15 will give me a growth factor of 0.85. And that's B. Okay, let's go back and figure out A. What is the initial value of the car? 32,000. Okay, so that's the A value. I now have both things I need, which are A and B. And so from there, it's just a matter of plugging them into this general form here to create the function we need. So this will be 32,000 times 0.85 to the x. So we'll go over to Desmos. It wants us to find how many years or how much time will it take for that car's value to be less than 5,000. So let's go back to Desmos and plug that in. So this will be f of x equals 32,000 times 0.85 to the x. Okay, well, the first thing I need to know to do here is I need to go to where 32,000 is. That's the starting point. If you get lost in your Zoom, you can just do like that. And then you just want to scroll out until you see the function. And then I want to find 32,000. Oh. And then I want to kind of zoom in on that. So zooming is kind of tough on your Chromebooks. So if you're struggling with that, let me help you. The easiest way to do it is to find it. And then for you, you'll double click on the value you want to zoom in on. So you want to zoom in on 32,000. That way I can get it to drag along there. Let's see. Right, so that's 31,000. That's going to take a while. So let's go back down. We're looking for $5,000. So let's go back down there. There we go. When is it going to hit that? That's it. 3,000, 4,000, right below $5,000. How many years does it take? Do y'all not know, or are you shy? 11 and a half or so, right? Or about 11 years. Notice, how much is it worth after 8 years? $8,345. How much is it worth after 20 years? About $1,240. Okay.
So is the decimal going to be like a whole number, or do we just like guess?
It's going to be an approximation, right? So if I ask you how many years, you know,
So
if it's
we have different answers, it's okay.
Oh, yes. There's going to be a range of answers that I'll accept there. It's not like you have to have the exact like number of days, months, seconds. If you said about 11 and a half years, or if you said 11 years or something like that, that's close for me, right? That's fine. This is just so you can learn to interpret the graph and what it means. But I'll accept those ranges of values. All right, let's go back and do the last one. Are these as bad as you thought?
I don't like them.
No, nobody ever does. It could be worse though. Let's do it again. Half-Life, everybody hates Half-Life, but Half-Life is relatively easy once we kind of get a handle on what we're looking at. So again, we are looking at the basic format, y equals a times b to the x. We're looking for an a and a b, and I need to know whether it is growth or decay first. Radioactive half-life just means that after a certain time period, the radioactivity has degraded or reduced by half. So if it's reducing the radioactivity level, is this going to be growth or decay? Decay. So my B is going to be 1 minus the percentage. So if my rate of decay is by half, what is half as a percentage?
50%.
50%. So as a decimal, that would be 0.5. And so then my B value would be 1 minus 0.5, which is just 0.5. Put some color on there. And then what is the initial value of radioactivity according to my little paragraph here? 20 counts per second. Ta-doo. So again, let's go write the function. All we need is an A and a B. And we've got that. So that's 20 times 0.5 to the x. And if we're looking for how long, how many weeks it will take to reach a radioactivity of 7 counts per second from 20. So we'll go look. Let's see, so that'd be f of x equals 20 times 0.5 to the x. And I'm looking for when that drops below 7. If you're really far zoomed out, you can hit the home button and it'll take you back pretty quickly. Because I know the pinch and zoom is a super big pain for y'all. So let's take a look and see when it drops below 7. There we go. How long does it take for me to reach 7? About 1.5 weeks. Of course, you know, you could be up here. That's still about 1.5. You're kind of close to 7. You're not going to get it right on 7. If you do, then you're amazing. Congratulations. I can't. The only way to get it exactly at 7, here's a trick. Just do it like that. But I'm not concerned with that so much. That's just a trick. You don't have to know how to do that. But it will give you the exact thing. All right, questions on these? Nah. All right, so you've got, I think, 3 problems, number 11, 12, and 13, on the assignment we started on Friday. So just go back and do those 3. I'm going to give you till about 10:30 to work on those, and then we'll jump into the new stuff for the day. We're actually making much better time than we did in first block, so you'll have more time to work in here.